In this video, we're going to continue our conversation about HVAC schematics. In the last video, I introduced shaded pole motor. If you remember, a shaded pole motor was basically a line and a neutral with a coil between it. Okay, didn't have anything else, didn't have two windings, only had a single winding. Okay, might be labeled run and common, but that's a shaded pole motor, a motor with a single winding. Now, in this video, we're going to talk about the rest of the types of motors, or at least the major ones you're going to see used in residential and light commercial. I'm not going to go into three-phase at this point, but so let's go ahead and, again, for sake of comparison, I'm going to put my shaded pole motor back in here. Okay, so I'm going to make it a little bit neater, just because I want to be able to reuse it. So we're going to do my winding. Okay, that's my shaded pole motor. So I'm going to go ahead and just label it so it's labeled. Get in a habit of labeling everything. And again, just for reminder, every motor has a run and a common terminal, okay? Doesn't matter what they're hooked up to, line 1, line 2, line 1 neutral. That's dependent on the voltage. But every motor has a line and or run and a common. Okay, so that is our first motor type, is the shaded pole. Now, we're going to expand on that shaded pole motor, okay? The next motor up is what we call a split phase motor. The difference between the shaded pole motor and the split phase motor is that the split phase motor has a start winding. Okay, it has another winding that helps the motor start when it's carrying a heavy load. So I'm going to go ahead in here and draw my, let's go ahead and draw my common in here. I'm just going to do a small little terminal there. Okay, I'm going to put a little, actually, you know what? I'm just going to copy that terminal so that it ends up in the same place. I'm going to put a terminal there. And I'm going to put a terminal there. The purpose for these different terminals that I'm basically drawing in here is that the windings all connect to these. Okay, so when I come in here, I'm going to draw a winding there. Let's erase that one. I didn't like the way that the one looks. So let's come back here. I'm going to draw a winding there. And now I'm going to give myself something to connect to. Okay, and okay, so now our basic split phase motor has 3 terminals, okay? We have my run, we have my start, and we have my common. How you wire these 3 terminals is what makes the difference, okay? So again, let me just make sure that that's sort of neat there. There's no break in the windings. Okay, much better. So I have a run, I have a start, and I have a common. Now, when you're looking at a diagram, okay, my run to my start is going to have the highest resistance because it's coming through both windings. So if you're taking an ohm reading, you're going to take 3 readings, run to start, or these 2 terminals, this and this. My run winding, run to common, is always going to have the lowest resistance. My common to start will have the second highest resistance. My run to start will have the highest resistance, and the terminal that's left over is always my common. So when you see resistances of motor windings, okay, the run to common is always the lowest. Common to start is my next highest. And the one that's taking across both readings, across both windings, which is the run to start, will be the highest. Okay, so this is a split phase motor. Now, when a split phase motor is wired into a circuit, we have to have some sort of switching device that is going to take out the start winding once the motor starts to turn. Okay, our most basic switching device is a centrifugal switch. Now, centrifugal switch is a normally closed contact that opens once the motor starts to turn and reaches 75% of its operating speed. So once again, it's a normally closed contact that, let's see if I can get a straight line across there. What do you say? Maybe. Cool. That worked perfectly. Okay. A centrifugal switch is basically a normally closed contact that will reach 75% of its operating speed, that is wired between my start and my run winding, that once the motor reaches 75% of its speed, that will open and drop out the start winding. Okay, so this is a split phase motor with a centrifugal switch as my start component. Okay, so that's a centrifugal switch. Now we're just going to move that over to the side, because that can actually be used on more than one motor. So this is split phase. Okay. And let's just go ahead and show this as I'm just going to show it as a CF. It could be a normally closed contact, but we're going to just show it as a CF. So my next motor takes my split phase motor and expands on it. Okay, I'm just going to move this down here so I can copy and paste my motor. Okay, so I'm going to take this whole motor and I'm going to copy it and I'm going to paste it down here, and we're going to make our next type of motor. Okay, our next motor is called a Psc motor. Okay, Psc. Okay, which stands for permanent split capacitor. Okay, so the biggest difference between the split phase and the Psc motor is one item. It's a run capacitor. Now, to draw a run capacitor, what we have is we basically start off with the same idea of our contact that we just drew, except I am going to take and we're going to just make let's see how we want to do this. I could do it one of two ways. Let's see if I can get a circle. That isn't what I wanted. Let's see if we can just do it with half a circle. I think I can do this. So now if I... Nah, that isn't going to let me do it. So we're just going to have to do this freehand. Okay, so what I'm looking for is that's my run capacitor. Now I'm going to move these a little bit closer together, just so it's one component. And my run capacitor, some people insist on having a dot next to it, so we'll just draw the dot in. Okay, that's the significance of a run cap. Now again, I can highlight this. I could shrink the whole thing in size. And if I put that between there and I connect this up, okay, it's a permanent split capacitor motor. I have my run, my common, and my common to start. So I still have a start winding, but the Psc motor will always have a run cap in it. And the capacitor stays in the motor the entire time the circuit is being used. Okay, so the purpose of this is to slightly make the AC sine wave or the pattern of the voltage and current shift for the part that's for the motor start winding. What this does, it gives it additional torque and a moderate running efficiency. Okay, so the start winding will be slightly out of phase. By out of phase, what we mean is we have, okay, AC current, okay, starts off at 0, goes up and comes down, and continues to shift across between a positive and a negative. Okay, and the peaks are dependent on voltage. What the capacitor does, it makes that start winding slightly out of phase. And again, this is not an even, okay, normally these are perfect loops. But any moment in time here, if I take a moment in time, I will not have two of these in 0 at the same point. Okay, so I will never have a 0 voltage on a winding. I will always have some voltage to help drive that motor. That's the purpose of the capacitor in that circuit. So let's go ahead and remove this bad drawing of a sine wave. Okay. And continue on with our motor types. Okay. Now, the next motor we have to worry about is called a CSIR motor, capacitor start induction run motor. Now, the CSIR uses a start capacitor. So let's come over here and let's talk about real quick the start capacitor, because we're going to use this. Okay. Actually, you know what I'm going to do? I'm just going to take a copy of this capacitor over here rather than going through this whole little nightmare. I'm going to copy that and I'm going to paste it over here. And I'm just going to remove my dot. Okay, and I'm going to call it start cap. And you know what? Let's go ahead and copy. Let's go ahead and just, again, let's get a copy of that just so we have it. And I'm going to put it over here and we're going to call it run cap. Okay, so a start capacitor has a higher capacitance. Okay, the run cap, as you might have remembered from class, okay, has a capacitance between 5 and 60 microfarad. The start cap comes up from 60 and can go on up. So I'm just going to use the whatever symbol, like it can go up to 250 and so on and so forth. The other thing is this run cap most often are metal. The start caps most often are plastic. Okay, so that is our difference between the starter and the run cap. So the Psc motor uses a run cap. Our next type of motor, which again starts off with a split phase motor. So we're going to just copy that again. No sense in redrawing everything. The next motor is a CSIR motor. So I'm going to go ahead and just label that so we don't forget about what it is. CSIR. Okay. And it is capacitor start, induction, run. Okay, so my CSIR motor, what we're going to use is we're going to use our start cap, but start caps cannot remain in the circuit. If you leave a start cap in the circuit, you are going to have your start winding and your capacitor burn out over time. So what we need to use is we need to use some sort of switching device that once the motor reaches about 75% of its capacity, we have to take that motor out of the circuit. So I'm going to introduce another symbol here, okay, or another component. It's called a start component. We are going to draw real quick, we're going to draw a current coil relay. Now, current coil relay is weird because it's a relay. It has a coil and a set of contacts. But that coil is based on it's based on very low voltage, but it senses current. So let's start off with a coil. We're going to keep this easy. There's our coil. Let's give it a connector on each side. And I'm going to pull that down a little bit because I sort of like these things to be somewhat even. So we're going to give it a connector. There's our coil. Now, as a part of this current coil relay, it also has a set of contacts. So I'm going to come up here and I'm just going to copy this because I sort of like these. They turned out good. Okay, so I'm going to come on here and I'm going to copy my set of contacts. But I'm going to remove the normally closed. The other thing is that this is all one component, okay? So what you can do if you want to, I'm not going to do it in this case, you can draw some dotted lines around this to make it all seem one component. So for example, what you could do is come down here and do that. But I am going to just leave, I'm going to leave it like that, but I'm going to label everything, okay? So what I have, current coil relays have a couple strange labelings on them. I have an L, I have an M, and then I might have a letter or an S or something like that, okay? Again, the point is that it tells you how to connect it to the motor. Okay, so I'm going to take this, I'm going to actually, I don't want I'm going to decrease it in size. Oops. Okay, sometimes lines get messed up on here before you get them all straightened out. So, okay, much better. I'm going to decrease this in size a little bit. You got to be able to grab all of it. Okay, and I'm going to move it up here. Actually, I'm going to make a copy of it first because I'm going to use this again. So let's go ahead and just make a copy of it. Okay, so what I have is I have a current coil relay that's now I have connected into my motor's run winding. M goes to R, L is my power feed. Now the only thing I have to have is I have to have my start capacitor. Okay, so I'm going to take this start capacitor. I'm going to create a copy of it. And actually what I'm going to do, I think, I'm going to try to rotate this. Okay, I'm going to take a copy of it and I'm going to take it down here and I'm going to rotate it and I'm going to make it small enough and I'll get rid of that because I don't need that. And then I'm going to go ahead and tie it in here. So now what I have is a CSIR motor, capacitor start, induction run, with a current coil relay. So just so you have it, I'm going to label this component down there. Okay, current coil. Okay, we have one more motor we have to talk about. Okay, and again, it's our next step up. Capacitor start induction run has a ton of starting torque, good for compressors. Most of the smaller compressors in refrigeration use this type of motor. But it doesn't have a lot of running capacity or running efficiency. So our next motor is a combination of our capacitor start induction run with our Psc motor. Now, the Psc motor, remember, the run cap is always in the circuit while the motor's running. However, if I put a start capacitor with it, I have to have another switching device that takes the motor out of the circuit all at the same time. So what I'm going to do is I'm going to come down here. Actually, I'm going to move this a little bit first to get it out of my way. I'm going to copy my Psc motor the way it is. I'm going to go ahead and copy it. And I'm going to paste it down here so I can use it for my next motor. Because my next motor is going to be a capacitor start, capacitor run. So I'm going to take my start cap there. I'm going to copy it. I'm going to paste it here so that I can use it on this motor. Now, because it is a start cap, I have to have a way to get it out of the circuit. The way we're going to do this is I'm going to do another type of relay. It's called a potential relay. A potential relay is actually really interesting, and you'll always know you have it because you will have a relay coil along with a normally closed contact. The potential relay doesn't sense current, it senses voltage. So let's go ahead and, just because I have a nice coil over here drawn that I don't want to struggle with again, I'm going to grab this coil. I'm going to get rid of my extra components that I really don't need. And I'm going to take this relay and I'm going to move it right there. Okay. Then I'm going to take my normally closed contact, and actually I'm going to do it that way. I'm going to copy this. And I'm going to paste this. I'm going to decrease the size of it pretty drastically and then rotate it. By the way, once I paste it like that, I basically have all one component. You see, it's no longer separate components. So I can move it around all as one. Once I copy with that little dotted line up there, I select some content. I now have a single component. Okay, so you can now, it basically acts as one. So I'm going to go ahead and connect this in. Okay, now the potential relay connects in 3 places. Okay, the potential relay will connect to my start capacitor. It will connect to my start winding, and it will connect to my common winding. Okay. Potential relay, again, has a normally closed, has a coil. It also has several pin designations. You will always see 1, 2, and 5. Okay, that is one component. The way this works is whenever I spin wire inside a set of magnets, there's voltage created. There's no difference in a motor. It's called back EMF. It's stray voltage that's created as the motor spins. This relay coil over here is energized by that stray voltage that's created. When the motor starts spinning at about 75% of its speed, it will create enough voltage to open this set of contacts and take out the start capacitor. Okay, so again, pin 1, 2, and 5 is always part of a potential relay. So let me go ahead and grab this relay so that we can have it for our and I know it's going to grab more than I wanted that. Okay, I am going to take out some of these extra lines. Actually, it may not. Yeah, it does let me take that one. Okay, so again, this relay right here, this set of components, is called a potential relay. Let me go ahead and write it there so we have it. Okay, pins 1, 2, and 5. So if I highlight this whole thing, okay, you now have all of the components that we talk about and basically use inside our motors and our motors. So this motor right here is capacitor start, capacitor run with a potential relay. So here's all the motors we're going to be using in schematics moving forward. Now, again, once you have a symbol sheet that you've created, it's very easy to cut and paste using the highlights, using the content selection in the PDF Expert from one diagram to another.